All right, this should be hopefully a quick and easy one, but just kind of talking about strengths of acids and bases and how to be able to tell if something is a strong acid or a weak acid. So it all relates to how easily the acid splits apart when you throw it in water. All right, so acids and bases, they form ions, H plus and OH minus, when they are in water. So, and we call that ion splitting dissociation. All right, they don't want to associate with each other, so they separate. So strong acids and bases will dissociate completely, 100%. They will completely break up into, H plus and the conjugate base, or OH minus and the conjugate acid. All right. Weak acids and bases, however, they don't dissociate completely, and how little they dissociate determines how weak they are. So, for example, H2SO4 dissociates completely in water. What would you call that chemical? All right, the fact that it dissociates completely should be getting you to indicate the word strong, but also, is it a strong acid or a strong base? All right, it would create H plus ions when it dissociates, so this is a strong acid. All right, now, for this next one, H2CO3 dissociates in water into H2CO3, so that means it doesn't completely dissociate, H plus and H3O minus, and some 2H pluses and CO3 2 minus. So looking at these different things, there's a few different ways there's some that you should be able to identify pretty easily. First off is the H2CO3. All right? Because it's got H2 attached to it, it's something that can give away a proton, which makes it an acid. And because it doesn't dissociate completely, it's a weak acid. All right? How about the CO3 2 minus? That is going to be a weak base. All right, because it can pick up hydrogen ions, but it doesn't dissociate completely either, because some of them are still stuck on our undissociated H2CO3s. All right. Something that you want to know that you're not going to have to do calculations with, but is the dissociation equation. All right, and this, you can also think of this as being a dissociation constant for any given acid. All right, you can calculate its strength and get an actual value by plugging in the concentration of H plus, aka your hydronium ions, the concentration of the conjugate base, multiply those together, and then divide it by the concentration of your water molecules times the concentration of your actual acid. All right, so the more dissociation you get, all right, the higher your numerator is going to be, and therefore the higher your Ka is going to be. So if you've got big Kas, that means your acid is stronger. You've got more dissociation.